Hello everyone, back again. This is Manna Mahmood and today we are going to discuss on normalization. And normalization, before we move to normalization, we must understand that normalization means the alignment of data for your purpose of operation. So, what sort of operation you are going to do on the data? So, before performing the operations, to make the operations more smooth, you prepare the data in such a way so the operations can happen smoothly. So, what are the basic operations in RDBMS we perform? That is, we call write and we call read. So, when you want to install RDBMS, they will ask you, do you want to install a transactional DB or analytical DB? Analytical DB means read operations happening mostly and write operations. So, in this perspective, this read means basically SQL queries. So, in case of analytical DBs, we sometimes have to align the data. We normalize in a contrary way. We do denormalize, and this denormalize means merging some fields again back into some tables, so we can avoid complex joining, complex queries, so the operation can perform smoothly. I mean, in this case, reading operations. In case of transactional DB, we have to optimize the most frequent writing tables, less fields, so we can write faster. So we have to make the most frequently writing tables, transactional tables with less fields. So we have to remove the already redundant things. So that is the alignment in case of this writing DB or transactional DB. In case of unstructured data, if this is not RDBMS but you are doing some operations, so in most of the cases in text we do tagging like location tagging, date tagging. Fully depends on what sort of operation you are going to do on those data. So if you want to get the dates or the word counts, so you have to tag those text on that way. So that is the alignment for those unstructured data. In case of statistical data, when they collect the data, they sometimes adjust the data for the measuring purposes, remove the decimals or give some concrete figures to fit in a scale. So these are also alignment for their data to do their operations. So this is a normalization, basically aligning the data for your operation. So we are going to today focus on this writing and transactional DB. So transactional DB, the main purpose basically we have to focus on to create a very good transactional entity. Sometimes we call it a link entity. And most of the cases we find this link entity already in second normal form. So that's something. But what is normalization is basically defined in practice for a long time on RDBMS. That there are three rules, basically three rules, and this is basically one sort of filtering data. So one filter, we can use the filter word called remove. So there is a remove, we call remove key dependency. Then we call remove non-key dependency. Then we call remove functional dependency. So there are three removes. It's pretty easy. Don't look at complexly. So if I discuss like what is key dependency, there is another name, people call it like remove repeating group. So that's the very first task when you get a order sheet or maybe a admission sheet or a enrollment sheet The most transactional records you get from the organizations, they do in paper on Excel sheets. You will see they are doing some admission, enrollment, or some billing, or some orders. So business transactions, they are keeping records. Those sheets you have to normalize to get aligned with your DB operations. You cannot normalize whole organization at once. You have to go functionally, I mean on transaction based. So you may get an order sheet, or you may get an admission sheet from university, or order sheet from a maybe from a retail company. So what you have to see, there is a very common practice, this removing this repeating group. There is a term everyone knows. Most of the softwares in last decades, even in currently, they use this term, that is called, yes, master detail. You know this form. So what is detail? Detail, there is a repeating. If you see a order sheet, you can see the order items are repeating. Order is one, but items are repeating. If you see a enrollment admission sheet and for university, you will see students are enrolling in multiple subjects, taking multiple subjects. Student is one, but taking multiple courses. So that taking courses are repeating. So these are called detail or repeating. So you can easily separate them. So that's the very first task you have to understand. And there is a common practice of separation. When you want to separate group of people or group of things, this is easy way to identify the leader. So here we call this key. So this is why we also call it key dependency. So you find out the key and the dependence on the key. We separate those groups. Like those 5 fields are dependent on that key, so make a group. 6 fields are dependent on that key, make another group. So this way it gets separated. Like if this is water item, so master will be the water ID key, and there will be some related water name and other things, water date. These things will be separated with the detail. There will be item ID, so it will be separated with item ID, item description, item price, this way. So this is we call number 1, like removing repeating groups. So this is the first normal. This is very easy. You don't have to have so much hard rule, first rule, like you have to do this way. It's pretty standard thing, and you can do it by just putting your eyes on the order sheet or on the transactional sheet. Then the second comes, this is called non-key dependency. Sometimes it also called partial key dependency. Partial key dependency. How like that partial key dependency? Like when you have separated, like maybe student table and then taken courses. So in taken courses, you have the student ID and the course ID, then maybe the course name and other things. So like maybe you have already a table called student. You have separated in first normal form, and then you have another maybe taken courses. But in these taken courses, you may see fields like student ID, then you will see course ID, then you can see maybe course name and other fields. So this is unique for these 2 key combinedly makes each row unique. So there is a composition of composite key, you can think like that. So this course name is basically not wholly dependent on this key, this composite key. Course name is basically dependent only on this one. So there is a partial dependency. There is a not full dependent. It is not full dependent. So what we should do, we should remove this partial dependent things, and we should make another table, maybe name course, and we should keep these fields like course ID and course name. So this is we call partial key dependency, or another name is non-key dependency. So this is a non-key. So you are dependent on partially, and you are just removed from that. So this way you are coming out of 3 tables now. You have a student, you have a course, then you have a taken courses. In third normal form, most of the cases maybe you don't need the third normal form, but in third normal form it happens like maybe in student table you have some attributes that are not related even with the student, maybe with the previous, like a student reference. So maybe student table you have reference ID, reference name, reference location, reference organization. This way you can have. So we called it transitive dependency. So the reference is basically not dependent, but maybe you can see like that student ID, and then there is a then reference ID maybe, and then there is reference name. So this reference name is transitive dependency. There is a transitive. This is basically direct dependency on reference ID, but it got an indirect dependency on student ID because it is dependent on that. So this way this is dependent on that, but this is indirect. So as this is indirect, we have to remove this indirect dependency. So this indirect dependency is calling basically transitive dependency or functional dependency. So we have to remove that. Then we can maybe make this reference another table and call it reference table. So that's the very basic thing. So we are calling it. So this way you have now complete 3 tables, and the 3 tables is basically I show you like student table, you have a course table, you have taken course table, and then from this you are deriving another maybe reference table. So now as we are talking earlier, like which one you have to now think, which one is transactional. Like student, they have once enrolled and the name is in the record. This is not that much frequent. Course table is not that much frequent. Once you enter the course names in the table, maybe yes. But taken course maybe for in admission office is happening frequently. Students are coming, semester are changing, and they are just taking courses, each on taking per semester 4 courses, 3 courses. So this taking course is, this is the, we call this basically transactional table or link entity. So I am going away from this normalization perspective to slowly to ERD mode. Like this is you can see it got a reference here, it got a reference here. So why we remove that? If you see this, what is the benefit of this normalization? If we kept the student name in this table, we have to write the student name again and again. So we are just keeping the student ID in this taken course, so we can refer the student name from this student table. We don't have to write in this, because we are writing this transactional table again and again, so we don't have to write this unnecessary student name again or course name again and again. Don't have to. So this is the benefit, and as this is linking these 2 non-transactional entities like student and course. If we say this is party and this is product, just aligning you with the 2P concept. So this is the party student and this is the product university is selling course, and this is the transactional table, the order business operation. That orders that is happening, this they are taking courses. So this is the operational where, and this is we call transactional table, and in cases we call it link entity. So let's jump directly from here to the ERD concept. I'm not going to go in very detail of everything, so you can have so many videos and the tutorials available if you want to go in detail of normalization or ERD, but I want to give you the gist that the way I think and the easy way, simple ways. And the ERD concept, basically from here, the basic thing in ERD that you must remind in your mind, in RDBMS many to many is never possible. It is never possible. It is not possible in sense of not law or rule. It is not possible in, logically, hardware, in writing. You can't do it. It will become a deadlock. You can't keep the product ID in sales table and sales ID in product table. So this linking entity many to many is not possible. So it happens. So if you say like you can do like student and course. So it's like if I keep student, like a student has taken a course, so you can think like a foreign key. I can keep a student ID here, so I can understand query that this course is taken by the student. Then I can again keep this course ID in student, another many. So this many to many is never possible. You can't put it like that. You cannot refer it, and it will not work. You cannot do query or you cannot do anything. So I don't know you understand or not. So many to many is never possible. So if many to many is not possible in DV or DVMS, how to manage that? How to refer that? Here comes the simple way. When you see a situation, both is referring each other. Like student is taking the course, then course is taken by the student. Like multiple courses can be taken by the students, and again a single course can be taken by the multiple students. This is the case. This is ideally this is many to many thing. So how to represent that in the DV? Then you have to do that with this link entity. We are calling this taking courses or student courses, you can call it, combining two names of the two tables. So this is the our transactional link entity is happening like that. What we are doing, we are making a relationship here one to many, and from here one to many. So this table is having a composite key like student and course ID together. Maybe you can also add the date or maybe the session ID of that semester. So it can have some other things depending on the transactional sheet what you are normalizing. Here you will get so many other informations tables. In third normal form you will find out removing all the functional dependency. You can find out from course, maybe semester, and then maybe session, then maybe batch, this sort of things, and all together it will give you a way that can break down your many to many to one to many and one to many. So now it's one to many, now this one to many. So rest of other things, understanding one to one, one to many is pretty something you can go through the things and other things. But what I want you to remind in your mind, in our ERD or in anywhere, there is simple thing that is nowhere many to many can exist. There is, this is error. So when you do any ERD or think like that, so there cannot be any many to many relationship. That's pretty simple thing, and I think you can easily find out rest of the things. And in normalization, the basic thing is basically there can be one row, each row must have a primary key. So there should be a primary key, and all the other headers or columns must dependent fully, not partially, on the key. So there should be no functional dependency, there should be no partial dependency, and there should be no and there the key dependents should be fully separate. So that's the thing I try to say. So I'm just repeating again. So it should be like there key dependent groups. First one is separating groups, master detail. Second one, in when you have master details, find out in the details mostly if there is any partial dependency fields partial dependent fields, remove those partial dependent fields, create another table. And then thirdly, if you see, maybe most of the time happens that first master table, in your master table you can see some transitive dependencies, like in order maybe you can find some company name and some other things, then you have to create a separate table of company. So pretty simple. So this is normalization. And in ERD, I just want to remember the basic that you must remind in your mind: many to many relationship is never possible. So there nowhere can be this many to many. Whenever you find a many to many relationship, you have to break it down. You have to make a link entity. So this is something like, if you do normalization, it will happen automatically, but most of the time you can think the schema or the what table should be there by just by thinking. You don't have to do the normalization. So in that cases, mostly the easy trick is find out this sort of entities and the many to many relationships and break down those into the link entities. So pretty simple, straightforward shortcut, but you have to test it properly. So now this is almost about the writing things. So you have to find out this transactional and make it less column and thing. And then this is read one. I want to talk about this read. This was right as a read. In read, when you do this normalization, this is a bit separate. When you read we do the separation, we have specific schemas. We called this star schema and we call another a snowflake schema. So these are two sort of schemas that happens in data warehousing. So the read database, whenever you say, you should understand this is analytical DB. Another name is basically data warehouse. This is pretty simple. In data warehouse, the schemas are called, so ERD, that ERD will do that ERD will represent basically star ERD, a star schema, and or maybe sometime extended to a snowflake schema. So what is that star schema or thing? So so in doing this, the alignment, data alignment, like in writing DB we are finding out the transactional table, and in reading database we have to find out that transaction from that transactional table, the measure fields. We called it measure fields. Measure fields, you can understand, there's something that is measurable. So I'll give you an example, like in sales table, what are the measurable fields? The quantity and amount. So all matters, nothing else matters mostly. These matters. So even if you sum up the amount, you can find out basically how much is the today's sale, how much is the month's sale, how much is this hour sale. So this amount field, ultimately this is the measure field of the business. You can measure the business, you can measure the transaction of the day, the revenue of the day, or the whole key KPI. If you say the operation is happening, indicator is that amount field. And then there is a quantity field, how many amount of product, how many quantities of product has gone. These things are basically, this is I'm specifically saying for the sales schema. In sales schema, in whole sales schema, these are the measure fields. So so when you are going to do this thing, so you have to do the queries mostly all the time relevant to amount and quantity. So the query will be amount and query. So in that case, you have to make this transactional DB the link entity that you may call like order details table or sales details table, where you are putting all the things maybe. So in order details table, you will have these two fields like amount and quantity. So you will have these two fields. So now this is the core center, and now you have to make a star. So what is the star? You have already made a star here. The transactional table looks a bit like a star, you see, like only two hands, like student has taken course. So there are two foreign keys in the taken course table. two foreign key. But in this case, like in star schema, here also like you will have a you have to refer this product ID, then you will refer a customer ID, then you will refer a order ID, then you will refer a time. You will create a timetable that is separately populated. There is a way of creating a timetable, so that timetable time ID for each row. Then you can have more other things like branch ID, if you have branches. Then you can have employee ID, maybe staff ID. So all these tables will be connected with these two measure fields as a foreign key, and these will be just only the measure fields to do the queries, the joinings, to find out. You can do this. This is star, and then there is a snowflake. Like product, you can like category. Like you can find out now, look for product ID for a single product. Maybe you are selling a shoe. For shoe, maybe you can find out easily from aggregating this amount and quantity, how many shoes are sold per day or per month or per week or per hour, and you can how much is the sale. And then you can also, if you do this category table, this is snowflaking. I'm not snowflaking, I'm creating bunch out of that main dimensional table. These tables are called, when you are in read database, called dimensional tables. So these dimensional tables you are when extending to another branch, then this is also your snowflaking like, and then this is become a category table maybe. Then you can say specifically on which category how much sales. Then in customer you can create another snowflaking, we call it geographical location, customer from which location or which branch maybe. Here we can also make a geo, so we can say the which sort of, or you can make a demographic like age. So you can say which sort of age people, which category is buying. Now you can feel like this is becoming analytical. Oh wow, you can say from Mirpur area or from maybe Dhanmondi area, which sort of customers are buying which sort of shoes, which sort of age people are buying which sort of things, what are the most transactional times. So you can from time you can maybe snowflake like season, maybe quarter. So this sort of things you can derive. So this is what we are calling this star and snowflake schemas. And this doing this, the aligning this, normalizing this, denormalizing this, totally based on the query or the reports that your management or the business organization frequently want to see. Today I think I already become half an hour, so let's finish it today, and next we will try to talk about the ERP modules. What are the ERP modules, how they are named in most of the ERP products. So we will try to introduce ERP.